So let's do some fun stuff. Let's render the digits and their associated values. So we're going to write a function here called print digits. And what print digits is going to do is it's going to take the actual cases and show them on the screen. So we're going to get them like this. Okay, I will just run that to show it to you here. So these are the digits. We're printing. This is the data that we saw earlier, right? And we're using that data to actually render the digit. And we're doing that using matplotlib here. So again, what we do is we set up a figure, and we set up a bunch of subplots, and we're going to adjust these so that because we have two sets of subplots. We have the actual images 0, 1, 2, 3, which are the images we're working with, and we have the corresponding dependent variable value 0, 1, 2, 3, because we know in our data we know that this is a 0, this is a 1. In the data we know that. We're not going to use that for the clustering, but we know that. We're going to use that for testing. So we have that, and we want to make sure that the zeros and ones are aligned with those things. So the purposes of the subplot adjust is to just make sure that they're aligned. If we don't do that, then we're going to get 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 ending somewhere here, ending where the 4 is. So that's not going to work very well. And then we work through this thing and add each image to the thing. We have the images here, and create the stuff and add the text of the dependent variable value, the 4, 5, 6, 7, 8, 9 stuff, the actual values. And so we have our images, we have our target values, and we know that there are 10. We're only going to show 10. We could show more because our data set is much larger, right? So this is what we get, and we get our image stuff over here. This is kind of a neat way of showing this stuff. The next thing you want to do is break stuff into a training and testing sample, because that's what we always do. So that's again very straightforward. We take a test size of 25% and break our we use the train test split function here and break it up into take the data and break it up, and take the target and break it up into two different sets, and we're going to get our thing here. We can take a look at labels. So the labels are, so the first case is a 5, the second case is a 2, third case is a 0, and that's what our y values are. And if you want to look at the x values, they will be x train is essentially our normalized data, the pixelated stuff normalized. So we can look at the unique values of y train just to be on the safe side, and we find there are 10 of them, which is right. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And that gives us our basic structure here. And the last thing we do, which we do always, is always the same thing, is we import the cluster algorithm, the cluster library module, and create a k-means clustering algorithm from that. We tell it to initialize it by doing some initialization stuff. So what k-means works better when you initialize it. So we initialize it initially. We run this pre-algorithm you can think of to do the initialization, and to start with because what k-means does is it starts by randomly allocating the digits, right? So it'll say, all right, I need 10 categories, and that's the number of clusters, 10, and it'll randomly assign the data to 10 categories. But if you can sort of intelligently start off and use some some knowledge about the data, like maybe the means and the values and all that kind of stuff, then you're better off. So you can use this k-means plus plus to actually start off the algorithm at a better point. And so that's the k-means. And then once we do that, we fit it. So fitting is going to be, of course, actually running the algorithm, and we've got this stuff running. So that's our stuff now. So now we want to actually work with this and figure out how well our clustering has worked, and try to understand whether we're getting a good result or not. And when we come back, we're going to move to that stuff there.